Let's finish it up here. User experience. What's it going to be like when we actually get to ride in these things? Or I guess some people already are, but I'm in Minneapolis. I'm not riding in these things. What's it going to be like to be riding in this autonomous vehicle, taking us from point A to point B? First things first, we need to be able to perhaps switch between modes of autonomous driving and manual driving. And there are a number of patents that address that problem. Switching between modes, a few of these patents have this list of tasks in an order in which they must be performed in order to transition from autonomous to manual, display a set of tasks to the driver or to the passenger, and then only switch upon completion of the one or more tasks. How to transition from manual mode to autonomous, provide a visual indication that the computer is ready to initiate autonomous mode. How to determine when the computer is ready to transition, display a first color indicating a ready status, and then a second color when the transition's been made. How do I transition to autonomous mode? Use a reference sensor to detect a reference indicator on a landing pad to access global coordinates and use a control module to switch to autonomous mode. This is an 8 million patent, which means it's an older patent. So there's a few patents out there where there's specific places on the side of a road where you could switch into autonomous mode. And I think this must relate to one of those. Okay. User input group here. How to indicate a user is ready to transition to autonomous mode. Receive an input that the user is ready to switch to autonomous mode and determine whether the vehicle can be safely controlled. Provide notification to the user of the transition and receive a second force input that the user has relinquished control of the vehicle. Last one here, how to transition to and from autonomous mode. Determine whether the vehicle is ready for autonomous control, provide notifications to the user and an input from the user, engage in autonomous mode, awaiting a second input to transition to manual mode, such as removing engagement with the steering wheel or the brake pedal or the accelerator, and then returning control to the user when the second input is above a pressure threshold. So, simple way to say touch sensors. Okay. Switching between modes, it goes on. Okay. And these are 8 million patents. So this is something they had thought about early on based on these numbers. Assessment, how to switch from manual to autonomous mode, receive a request to switch, assess vehicle environment, systems, and driver, and identify driving conditions from a plurality of assessment and associated tasks, generate a set of tasks and display them to the user. Once completed, switch to autonomous mode. Sticking with our task list there. The map one, identifying a landing strip and a reference indicator. So that's another landing strip one. Second to last one, steering wheel grip, how to detect a driver's grip on the steering wheel, have the vehicle send an instruction to a steering wheel, monitor the movement of the steering wheel by a torque sensor to generate data, and determine whether the driver is gripping the steering wheel based on that pattern data. Last one is user request, how do I switch to autonomous mode? Receive user input request, process the vehicle environment, and generate a set of tasks completed. Another task list one. Okay. Any good pictures here? There you are playing on your phone while driving. And we have we even have a Google brand label on the steering wheel. Good. All right, passenger journey. What does it look like from the point of view of ordering the car, getting on the car, driving in the car, getting out of the car? What is that going to look like for us? Well, let's find out. Pickup requests. First things first, I need to arrange a pickup. How do I do that? Upon pickup request, I identify various potential pickup points, and I use a set of heuristics to rank and identify a location for display on the client's device. So I'm going to tell the client the best place to pick them up. Dispatch, how to determine when to dispatch the vehicle, identify a time to walk from a first location to a second location, and if it's beyond a specified time, send an autonomous vehicle. Pickup preparation, how do I determine the direction of arrival? Use a radar unit with a plurality of antennas that are spaced from each other to allow calculation of an angle when directed by radar. So somehow determining my angle of arrival using that information. Pickup notification, how do I provide pickup notifications to the passenger? When the vehicle nears the pickup location, send a notification to the passenger, and then I stop and initiate a countdown to await for the passenger authentication. And then if I'm unable to do so, I provide a second notification, and then I cancel the trip if after 3 notifications, the passenger still hasn't shown up. So even autonomous vehicles are impatient. 3 strikes and you're out. The last one here, how to pick up a passenger. Attempt to find a parking spot within a predetermined distance of the passenger pickup location. Determine that you're unable to find one, and then move the pickup location and stop for a predetermined period of time somewhere else. Okay. Have we picked up our passenger yet? Yes, our passenger has arrived. How do we know that this is the actual passenger that requested the ride? Well, one thing we can do, we can identify a set of pedestrians near a pickup location. We can receive information from a customer device and estimate from their device the customer's velocity in order to identify the subset of pedestrians likely to be the customer. So the customer can be walking along with a group of other people, and we can figure out which one is them based upon the movement of their device. Interesting. Okay. How to identify a waiting passenger. When near the pickup location, attempt to authenticate a passenger device and determine if the pedestrian is within a threshold distance and stop near the pedestrian rather than at the pickup location. So by knowing where they are, we can perhaps pick them up before they get to the actual pickup location, save them some time. Passenger verification. How do I confirm vehicle occupancy? Here's one answer. Take an image that's displayed on an interface, receive an operator confirmation that the desired occupancy has been met. Here's another one, how to verify the number of passengers. Send a request for a remote operator to verify the number of passengers in the vehicle. Second to the last one here, car identification. How do I ensure that the requested car is identified by the user? How does the user know that they're getting to the right car? What we do here is we allow the user to select a predetermined color associated with their request, and then we display that color on a vehicle display so they know they are at the right car. Bottom one here, an unassigned passenger. How do I identify an unassigned passenger? Well, in this case anyways, I pick up the passenger, and while driving, I compare the vehicle location to the location of the requesting passenger's device, and I determine that the current passenger is not the assigned passenger or is the assigned passenger, depending if their device is moving in the same way that the car is moving. Okay, what else can we do to make the passenger's experience more fun? We can close the door for them, door closure. We receive a signal that the component's open, and we send a triggering signal to an actuator to close the door. How nice of us. Passenger interaction, how to provide route options based on the amount of driver interaction. Receive a destination, display a number of routes, including the amount of manual driving required for the trip. Manual autonomous routes, we can suggest a driving route by generating proposed routes that visually indicate autonomous and non-autonomous regions. Route determination, here's an interesting one. We can choose our route by calculating a motion sickness value of various routes and choose a route based upon a total motion sickness value. Third from the bottom, how to provide remote assistance to a stopped vehicle. Determine that the vehicle has stopped and that review criteria have been met. Provide an image to an operator for input and provide instruction to the vehicle via a network. So there's our call for help again. Second to the last one, flyby passenger pickup. If I can estimate the amount of time that it will take for the passenger to either enter or exit the vehicle, I can determine a place to stop based on that estimate. If they're fast, I might actually stop in a lane of traffic. If they're slow, I might have to actually park on the side of the road. Passenger drop off, how to provide an end of trip sequence, generate a display of a projected trajectory along with the objects in the trajectory from a first relative position. When the destination is approached, change the angle of view on the display to provide a sky view perspective of the vehicle to know that you've arrived. Okay. How do you know it's your car? There's a lot of customer journey patents here. All right. User display, and maybe the way to think about user display here is how do I trust my car sees what I see? How do I trust that the car sees the cyclist, the pedestrian, the other cars in the lane next to me, and so on? And the display looks to help with that issue of trust. So display, what are the different things that I can display? Lane markers, driving lanes, objects, the internal state of the vehicle, and the vehicle path. Going through these, I think we're reaching the end of our time. We might go a couple minutes over, but we should be pretty close here. How do I use the map data to assist in identifying lane markers? Use first and second detected positions to determine a third position and display the lane markers on that display. Driving lanes, I receive geographic position data and I use my current location to access a map and I identify locations in driving lanes. Objects, I display the objects and their relative likelihood of impact. So on that display, that's probably not a way that you would communicate it to the actual passenger, but things that are closer might be a different color or a brighter color than things that are farther away. Internal state, I want to know, is the vehicle seeing what I want it to see? In this one, it's identifying a traffic light and displaying a representation of the vehicle and the traffic light and the state of the traffic light. Second to the last one here, how do I display objects? I identify an object and its trajectory, and I display the object and a warning indicator when it meets a threshold. Vehicle path, I also display that. I use a color scheme where objects that are more vulnerable to impact have a different color than objects that exceed a threshold distance or trajectory. Some more displays, how to display the vehicle path, vehicle and a segment of the path that it's following to show objects relative to the vehicle. Here's an interesting one, an acceleration event notification. If I'm going to accelerate, and there's a threshold that's going to be met, I want to give a notification to the passenger that I'm going to be doing that. Maybe that fits with that motion sickness one from earlier. How do I display object-based indications? I display an identified object on a screen and a warning icon relating to the object. Another internal state one, receive GPS location information and stored map information of lane orientations, and display an object indicating that the location of the vehicle is in the lane. And then prior to switching lanes, I show a projected path of where I'm going to switch into or turn into. Internal state, receive destination information from the user and location and GPS components included, and identify a route using the stored map, but determining if the vehicle must wait before proceeding on the route safely, and displaying a portion of the path to the user that indicates that we are waiting for something. And a few more displays here. How do I determine the controlled device mode based on user location in a vehicle? So depending where I'm sitting in the vehicle, I might be able to control different functions of the car. Safety, how do I display objects based on relevance to safety? Yet another one of those displays with different colors for different nearness of objects. And then last is how I display a yield event. So I will display the object, but I will also display a yield sign indicating that I'm yielding to that object. So here's some pictures using the map to develop the lane information, the trajectory that I plan to take when I make my turn. Here's a left turn, maybe worth a look here about if there's more details in the patent itself. about that. Here's switching lanes in front of another car or having someone switch in front of me and so on. And all kinds of good pictures. And they have there's another type of patents called design patents. And so for these displays, they have these design patents of different little pictures you can take a look at on your own of what their display might look like. All right, user preference and safety is what we have left. If I'm a user, I might have certain preferences. I might want to allow for user inputs. First input for initiating autonomous mode, second for stopping the vehicle. A driving pattern, I can generate a driver-specific profile by evaluating driver preferences over a series of driving trips. I can tell them how I want the car to behave as far as acceleration profiles and things like that. How do I modify speed based on traffic conditions, receive a driver preference for speed control, and you can identify a second vehicle exhibiting those preferences and control the vehicle according to those preferences. And then the passenger compartment, they have this patent here on a front where you sit in the back seat and the front seat folds down so you have more leg room, which we'll see a picture of that. Here you go, the front seat folded down so you have more leg room. Okay, and last here is safety. We have, once again, the airbag that moves. It has a locking feature, but it moves relative to the vehicle prior to deployment. Remote assistance, transmit an assistance signal to an assistance center, and the request for navigational information includes objects in our vicinity, and we receive a response signal from them. And then occupant safety, so here's an interesting one, occupant safety, how to assess the safety risk based on occupant position. So determine the passenger safety risk for a first and second trajectory based on where the occupant is within the vehicle, then the vehicle will have a different safety response. So that is a very thoughtful idea. Okay, there's your moving airbag picture. And okay, I've got 2 slides left, but